In the previous video, we saw examples of using a equation, like a formula, and a table for a function, but often functions are represented in graphs. So in this case, we have a graph of y equals g of x. So g of x is just the name of this line. We're giving it a name. They want us to find g of 0. Whatever's in the parentheses, that's our x value. So we need to find where x is 0 and then go up to the line and find y. So if x equals 0, then y equals 2. So what that means is that g of 0 equals 2. Just 2 is the answer when it's phrased like find g of 0. It is a point, right? It's the point 0, 2. Yeah, I don't want to put it over there. But I want to emphasize this idea. When they're asking for g of something, they're asking for just what is y. Okay. So hopefully that one makes sense. What is the function value at 6? Okay, at is that indicator of where x is. It's a location. Locations are x values. So we find where x is 6, and then we go down to where the graph is. So this is the point 6, -2. But what they want is to say g of 6 is the y value -2. The function value is the same as the y value. So we're just practicing with this new notation. All right, this is what is the solution to this equation. So this time they are giving us a y value. And we're supposed to find x. Okay, so we go over to our graph. Here's y equals 4. And I'm just going to go over to where it hits the line. So this is the point, -3, 4. So then the solution, the x value, is -3. And I'm putting it in curly brackets because we solved an equation, weirdly. But x equals -3 is the value that goes with y equals 4. All right, next one says solve g of x equals 6. So this is y equals 6, and we're supposed to find x. So here's y equals 6. We go over to where the line is. This is the point -6, 6. So the x value is -6. They gave us y, and we found x. When it says find the solution or solve, that's when we tend to use curly brackets. All right, state the domain and range of g. This one's a little different. Before, when we did domain and range, we listed out x values for domain and y values for range. Because we were given like a list of points, or if it were on a table, same thing. This one's different because we can't just list the x values because there's infinitely many. We could do like 1.5 or 1.55559999. That's one of the x values, so I can't list them. So instead we use intervals. So we're going to use intervals when we can have decimal values. When x or y can be decimals. In other words, we can't just list out the whole numbers. All right, well, so what the domain is then, we're going to use an interval. And an interval is when we use either parentheses or square brackets. And we always go from low to high. So what it's asking for is what is the lowest x value that this function can have? Lowest x value. So let's follow along the x, side to side, negative, negative. Oh wait, there's this arrow. That arrow means it goes down to negative infinity, to the left. And this is left to right for domain. Let's do the same with the highest x value. If we follow this all the way here, the highest x value, well, this arrow says it goes to positive infinity. So when we go left to right, our domain is negative infinity to positive infinity. Okay, and we're going to do more examples of these in later videos too. Range, same vibe, except now it's y values. So we need to go lowest y to the highest y. And that's up or down. So we start at the most downward position and work our way up. So if we go all the way down, this arrow says that this line keeps going, going, going. So we can go down to negative infinity for y. Okay, well, let's go up. Let's find the highest y value. This arrow says the highest y value is positive infinity. So if we can hit any x or any y, then our domain and range would be negative infinity to positive infinity.